In this video, I'm going to cover a few examples of integrals with powers of tangent and secant. So here are the three, oops, I forgot my dx. I've got my three examples that I'll go through here. You can pause the video if you want to check them out, but let's just get right into them. Actually, one thing I will point out, I've got cosecant down here. So cosecant and cotangent kind of work similar to secant and tangent, so I just kind of looped it in there in case you wanted to see one. Okay, let's get to it. Okay, so let's just jump right into it. So there's a little bit of a nuance with these types of problems. So the thing that I find helpful to remember is that the derivative of tangent is secant squared, and then the derivative of secant is secant tangent. So what this tells me is that when I have like even powers of secant squared, like I do here, that's going to dictate a u substitution in one way. Versus if I have, let's say, like an odd number of secants and tangents, then I might want to utilize this derivative with a u substitution. And this is just a suggestion. Like this won't always get you there, but this is kind of a way to wrap your head around it. So, okay, let me get rid of this. So in this case, I'm going to set my u then equal to tangent x. So my du then is secant squared x dx. And so then this is actually a pretty simple integral in that it's just u squared du. So this is going to equal 1/3 tangent cubed x plus c. Okay, so for this next one, so now I've got secant cubed tangent x. So now I have like an odd number of secants and tangents, and I have just this one tangent. So now I can think of separating this integral into the pieces. So secant squared, secant x, tangent x. Okay, and so now I can do the other substitution I was talking about. So now my u can just be secant x, which makes my du secant x, tangent x. And so now I can rewrite this as u squared du. So it's almost like the same thing, right? And so then this becomes 1/3 u cubed plus c. Sorry, I forgot what my u is. 1/3 secant cubed x plus c. And so there you go. So now let's do one with cosecant. So I've got cosecant to the 4th x. This could have just as easily been secant to the 4th x. Very similar problem strategy. Okay, so once again, now that I have an even number of powers of cosecant, my immediate thought is to break this up as cosecant squared x and cosecant squared x, because then I can use the fact that 1 plus cotangent equals cosecant squared x. So this will be 1 plus cotangent squared x, cosecant squared x. And now I can go ahead and I can set my u equal to cotangent x. And so then my du will be negative cosecant squared x. So I can put the negative on the outside and rewrite this as 1 plus u squared du. So this will come out to u plus 1/3 u cubed, and then of course the plus c. So in the end I have negative cotangent x minus 1/3 cotangent cubed x plus c. And so there you go. Okay, and so that's it for this video. If you found it helpful, please consider hitting the like button. I will catch you guys in another video.